to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, my name is Leonard Facchinetti, and let's write some code together, shall we? What we have on the menu today is a follow-up to yesterday's coding session. We are going to be implementing the hold parameter on the Automixer for video. And in case you need a little bit of recap, we have been working on a series of real-time audio effects using the JSFX language in REAPER. And in particular, right now we are working on this effect called Automixer. And what it does is to mix automatically multiple microphones that may be open and recording in the same room. And that prevents when one person is speaking from their voice to be picked up by all the microphones in the room, resulting in more of a reverby kind of effect. And the Automixer that we are developing is different from any other Automixer that I know of because it allows you to switch to different cameras in case you have some kind of round table or interview where there are multiple microphones and multiple cameras. You can switch to the person who is speaking and the camera will switch to that person. And Bo is here on the chat. Hello, Bo. I am doing well. I hope you're doing well too. And Mage Prometheus is here. Hello. Perfect timing. I just had time to catch up with this week in Rust before they start. Okay. Okay. All right. So let's dive into the code. We are implementing this Automixer for video. Yesterday, we did the whole setup to do the attack parameter, and that is to allow a person to start speaking and just wait a little bit of a grace period before we actually switch to them. That's what we implemented yesterday. Today, we are going to be implementing the hold parameter. So after we do one camera switch, we are not allowed to do another one within this grace period. And the purpose of having this is to prevent flickering, where for whatever reason, the Automixer gets confused about who is speaking and then starts switching cameras too fast, which may happen when two people are talking on top of one another. So I guess the best place to start with this is... Oh, and Tail is here. Hello, Tail. It's great to have you here. Looking forward to talking to you tomorrow. And for people who are watching this and don't know about it, tomorrow, Wednesday, we will have Tail over here on the stream and we'll be talking about Clap, the new standard for plugins. And he has developed some plugins using his own fork of iPlug that support Clap. And he will be sharing his experience with us. Anyway, so I guess the best place to start is to try and come up with a test case for this hold parameter. I have here one setup of the Automixer that is more like organic because it is listening to my microphone, but I want this test to be somewhat repeatable. So I'll come up with a separate test here using just some sine waves to represent different people. Because that's how I work. When I am talking to someone, that person better be a sine wave. That's how I make friends. Anyway, we have here a setup to show attack. And you can see that when person 2, who is louder, starts speaking, it takes a little bit of time before the scene switch actually happens. That's why you see this line coming up after this transition. Let's try to come up with something similar, and in fact, let's annotate, because I think that perhaps this REAPER project will become sort of a test. I want to say like unit tests, something like that, for the Automixer. Anyway, so let's give this region the name attack. And then let's come up with similar, but not quite the same scenario over here. So for the hold parameter, what I want is for one person to start speaking, but only briefly. So what I want to have happen in this scenario is someone is talking, the camera is on them, and then perhaps they're catching up their breath or something, and someone says like, I don't want the camera to switch to that second person. I want the camera to continue on the first person. Now, because of the attack parameter, this may already occur, but we'll see if we can come up with just the right length for the attack to not work. And then, oh yeah, I said that I didn't want to switch to them. I guess in this case, I do want to switch to them. So I will want to switch to them, but I don't want to switch back to this person immediately because of hold. Let's see how this plays out right now as it is. Let's double check that we have the Automixer set up correctly, and then we can enable this for, it's already enabled. We can just start recording and we'll see the camera switches as sort of audio coming out of this track. It's a bit of a weird setup. That's what we came up with yesterday. So this is in group 1, it is track 1, and video is enabled. And let's make the attack fairly short. Then this should be in group 1, video enabled, and it is video track 2. This should be good. Let's record. Okay, so this is what I'm talking about. First of all, I guess 100 milliseconds was not too long. It was just this tiny bit. And for whatever reason, when the other person started speaking, there was a bigger gap here. Isn't that weird? Let's play this again. Yeah, it seems to be consistent. Is hold already working by magic? I don't think so. But for whatever reason, it decided to go to person 2 very fast, but to come back to person 1 somewhat more slowly. Odd. Anyway, what we want is to have this little period here extend. If we make the hold large, we want this to extend for a long time. So we will be showing someone who is not speaking at that point, but that's just because we have decided to switch to their camera, so let's not switch back so fast. I do want to play around with the different attack lengths, because if it is long enough, then we should not switch to this person at all, because they don't speak for long enough. And we are almost there, I think, because I made the parameter bigger and the gap is a little longer now. So if I do something like this, I'm fairly certain we'll never switch to person 2, validating that the thing we did yesterday with attack really does work. And it seems to. Perfect. But if we make it slightly longer again, yeah, we switch to them. Now, what's up with this gap? Very weird. Anyway, once we introduce hold, we'll be able to make hold very large, and this line should go to the right. That's what I expect anyway. Let's see what you all have to say. I'll just listen what here is happening. Oh, hello, Suits. And that's what I often do when I'm watching streams too. I'm doing something else and just sort of listening to the stream. Right, we already did all the boring work of setting up the slider. It is already computing this thing, even in terms of samples when we need it. Yeah, right there. Not sure we are going to use this, but we are computing it. So the difference between yesterday's slider and today's slider, namely attack and hold, is that attack is a notion that is self-contained within one instance of the Automixer, as far as I conceptualize this. The plugin, the instance becomes the loudest microphone in the room. It becomes the person who is speaking. And then we, that instance, will set ourselves as the scene. So we switch to us. But we are only allowing ourselves to do it after this length of time has elapsed. But with hold, that's a somewhat different concept in the sense that it is a concept that is shared amongst all instances in the group. And I thought about two ways of going about this, and let me know in the chat if you have a preference, if you think that one is going to work better than the other. Or maybe you have a different idea altogether. But one way that I thought about doing this is when the instance becomes the scene that is on the screen right now. So it becomes the camera has switched to that instance. Then the instance could be in charge of waiting for the hold period and then communicating to the rest of the group, okay, I relinquish the right of being on camera right now. If someone else wants to take that role, you are allowed to. So the instances would coordinate cooperatively. They would sometimes switch to themselves, and then they would sort of lock, and no one else would be allowed to switch. And then they would cooperate with the other camera angles by saying, okay, I have been on screen for long enough. I allow anyone else who wants to take charge to switch to them instead. And of course, that will only occur if someone else is louder at that point, if someone else is speaking. So that's one way I thought about doing this. The second way I thought about doing this is when I do a camera switch, I record the exact time in which that happened. And I have to think of this in terms of time. I don't think it would be very ergonomic to think of this in terms of samples because this clock, so to speak, needs to be synchronized across plugin instances. And the notion of samples is hard to keep track of across plugin instances. It's not impossible, but it is a bit weird. So I thought about just not using this in terms of samples, looking at the camera switch in terms of time. And then what's different about this second approach is that we don't require the camera that has switched to be in charge of bookkeeping. Because any other instance who becomes the loudest and has waited for long enough can look at the clock and see, okay, the hold period is already over. I will go ahead and switch. And what's good about this is that the role of bookkeeping is now distributed amongst all the instances. So if I went with approach number one, I think that there could be an edge case in which a camera switches, but then for whatever reason, the plugin goes offline, maybe because of automation, maybe the person deleted the plugin instance, whatever the case may be. So the plugin becomes offline and it never has the opportunity to cooperate and say, okay, other threads, other plugin instances, you are allowed to take over the camera if you want. So I think that approach number one would be somewhat simpler to conceptualize because In that case, we could look at things in terms of samples. We could do a similar counting that we do to deal with attack to implement hold. But I don't think that option 1 really cuts it. I think that option 2 is better, and I think it's better to conceptualize this in terms of time. And then when a camera switch occurs, we record the time when that happened. And I think that this is even going to extend better to when we get to fancier features. For instance, if a camera has been on the screen for too long, we would like to cut to a wide angle view or cut to someone else just for variety. So this cut would be writing to this same place, and then the hold would just naturally work. While if we do this special case of implementing hold on the instance that set itself as the main camera, that could not work. Let's hear what you all have to say. Hello, everybody. Hello, Seawits. Is that hold caused by a time window used to calculate the average volume? Yeah, the point of the hold is it's not really caused by a time window. It is just, and it's not really about the average volume. So we have a notion of average volume that we use to compute who is the person that's speaking, what is the loudest microphone in the room right now. And we use a notion of average that we call RMS to compute that information. Yeah, so this notion of hold is not really related to this time window that we use to compute who is speaking. This notion of hold has to do with the camera switch. After the camera has switched, which is based on but not quite a one-to-one relationship between the person who is speaking and the person who is on camera. So after a camera has switched, we want to hold on to that angle for a little window, and that's what this hold variable is. So yeah, I think that we will not reason about this in terms of samples. So let's remove this computation. We don't need that variable. And let's go with approach 2 for now. Let's store the time in which a camera switch has occurred. And we'll see if this strategy pays off. But one thing we know for sure is that this timestamp needs to be visible by all plugin instances in the group, because they all need to respect that hold. So let's have another field in the data structure for a group. Some of these fields have to do with synchronizing sliders, so that if you have multiple plugin instances on the same group and you switch some sliders around, the rest follow. So most of these have to do with syncing sliders, but now we have a field that doesn't really have to do with syncing the sliders. It has to do with bookkeeping camera switches. So let's see where this goes. I think it goes right here as the last item. And this will be the camera switch hold. I guess I'll call this the last switch. Perhaps I should be calling this transition. I don't know, whatever. Now, there are 7 pieces, 7 items on this data structure. And the first thing is I need to write the current time to this variable when I do a camera switch. So let's go way below in the code and find the place where we do a camera switch, which is right here. At this point, all the conditions have been matched, and the plugin instance is ready to claim itself as the current camera that is showing. Well, this structure doesn't really work like that. Let's get a hold of that one. I don't think that this is correct either. I have 2 holes to fill here. Let's start with the timestamp, which is easier. We already have a notion of timestamp somewhere. Oh, but only for samples. That's kind of interesting. Well, I think we will need something like that for... Oh, but hang on, we are in the sample section. I was thinking for a moment that we were in the JSFX section just because we are dealing with video, but no, we are in this section, so we can just use this notion of time. That's easy enough. That is already part of the library and it is keeping track of time, so we are good. Just want to make sure that we are calling the block function. Yes. And now I want to make sure that this is where, yes, this is where we set that variable. Perfect. So this is the current time, and I could just call time precise again, but that's a waste because calling this function is somewhat expensive, and this is better. We are only calling it once and storing its value. Now I need to come up with the address under the global memory that corresponds to this group. We will want, I guess we will want to have something like this. But we can also cheat and look at what I do to get, for instance, a hold of that. Let's see, this is a constant, I think. Yes, this is a base address. It is a constant. Then in each group, that seems to me like a loop variable. And it is a loop variable, so perhaps that was not the best place for me to have copied from. That seems like a better place for me to copy from. Yeah, let's double check. So this is a base address. It is a constant, then group. Well, it's probably a variable that exists because the previous line is using it. So let's continue. Gmem group, I think that is the size of the data structure. It is the size of the data structure. And then this is the field within that data structure. Perfect. I think that this is the right thing. I think that with this line, we are writing the timestamp of the camera switch. Now, we need to check this time before we are allowed to do a camera switch. I think that the way we can do that is by checking how much time has passed. So this is the current time. This is the time of the last transition. And this subtraction is guaranteed to be a non-negative number. this is how much time has passed since the last camera switch. And this is a time given in microseconds, I think, because we are using time precise. So I think I need to divide by 1,000, or perhaps we have some microseconds to milliseconds. No. Let's double check the precision of time given by time precise. It seems to be at 1 millisecond. Oh, returns a system-specific timestamp in seconds. It is in seconds. Perfect. Okay, now that we know that, this needs to be in terms of milliseconds. Do we have a library function for this? It is just a division or multiplication, but I can never tell if it's a division or a multiplication, so probably there should be a library function for it. No, there isn't yet. Maybe in the future there will be. Anyway, I want to compare this to the slider that is given in milliseconds already. So what we want is for this time to be greater than that time. We want it to be greater than because that means that more time has passed than the given hold time. But there is a problem. This is given in milliseconds and this is given in seconds. So I'll have to think hard and convert milliseconds to seconds or vice versa. It doesn't really matter in which way I do it. It will only take me about an hour to get it right. Let's see what you have to say. I think the winner should be the process that handles the whole timer. Oh, so you are in favor of option 1, it seems. In that the winner would... Oh, yeah, thanks. Thank you. So the winner would be looking at the clock and saying, okay, enough time has passed, I relinquish the right of being on the screen if someone else wants to be on the screen. Fair enough, it is a good strategy. But I don't know, I'm worried about that just going offline and then not no other camera switch would occur. And the only fail-safe I can think for this is for other instances to look at the clock of the last transition. So it ends up being solution number 2. Do you think that this would be a problem? And can you imagine some other solution? Let me know. Yeah, so milliseconds is times, it's seconds times 1,000. Thank you. So what I need is this. Oh, fuck. I need to multiply by 1,000, but which side? So this will be a large number, like 1,000. And this will be a relatively small number, like 1. For 1 second, this is 1, while this is 1,000. So I need to multiply by 1,000 on the left, because 1 second will become 1,000 milliseconds, and then I can compare to milliseconds. There you go. I did it. Awesome. But that's not all. I still need to combine these two conditions. So first, there is this condition that has to do with attack, and then there is this condition that has to do with release. With hold. God damn it. This condition has to do with hold. But that's not all. Because the way that we are doing attack is we are starting to count up from 0. As soon as we become the person who is speaking, we start counting up. And when we get to that number, we switch. But now we may get to that number while the hold is still going on. So this condition would be met, and this condition would not. What we want is to just wait until this condition is met, but then this won't be met anymore. See the problem? So I guess what we want is to check for greater than. But then there is another problem. And the problem is, if we check for greater than, then this will start to hold, while this may not, because not enough time has passed. So at some point, this will be true, and that will be true as well, because both the attack and the hold times have passed. And then we'll do the camera switch. But then on the next time we go around, these two conditions will still be true. Well, I guess this will not be true. But then wait for a second or two, and this condition will be true again, and then we are switching to that camera again, which is not really the intent. We only want to switch the camera if we are not the current camera. So what I want is to check that these two are different. So really this becomes the condition to allow for a camera switch. Well, it will get a bit more complicated because this attack +1 situation will not really work. We'll see. But the condition for a camera switch is we need to not be the current camera. We need to have been the current camera for a while, the attack. And we need to be outside the grace period. Okay, all of that sounds reasonable to me, but there is still the issue of this. This is resetting the attack anytime that this condition doesn't hold. But really, we should only be looking at that before we reset the attack. So I'm going to have a variable called video. And I think we had this variable at some point yesterday, but it is like oh, no. I'm misreading this. This whole condition is inside this body. So never mind that. We are only doing this if we are not the current maximum. We are good. Yeah, let's go over this again. If we are the current maximum, we are going to do a bunch of things. If we are not, we are just resetting the attack, which is completely okay. If we are the current maximum, we start counting up because we need to satisfy that attack. I'm thinking of another way of doing this. Instead of having this condition here, which is a sensible condition, but it may not be ideal. It may not be the best way of representing this. So how about we do it like this? This way, we are capping this number to never go beyond attack. And what's nice about this is, first, we don't need to check that we are not the main camera. Oh, I guess we need to check it anyway, because as soon as this condition is met, it will continue being met. But there is another reason why I think that that may be a good idea. And that is this number could be growing larger and larger, and it could overflow. Which is a bit ridiculous because we are talking about 64-bit floating point numbers, doubles really. So it will not overflow anytime soon. But in theory, if this number becomes large enough, in theory, if the same person is speaking for long enough, which is probably going to be billions of years, this number could overflow. So with this solution, it doesn't overflow. It is what it is. Whatever. So now we can check for equals, because as soon as we get to that number, we stop counting up. And then we still have to check that we are not the current camera. We check that we have achieved attack, and we check that we have achieved hold. Then we set ourselves as the main camera, and we look at the clock, and we update the time. Great. We didn't change a lot of lines of code, but boy, let me tell you, those are difficult lines to write for me. Let's see if we can get this working. You know what? Before I do this whole setup, maybe I made a mistake and someone is telling me so in the chat. Yes, exactly. No lol. Yeah, I see. What I meant was if you have seconds but you need milliseconds, then you need to multiply by 1,000. It will actually stop adding long before it will overflow. Oh, I see. Interesting. So if you try to add 1 to a floating point number that is about to not be able to take that number, it will just round, lose precision, and it will not overflow. Well, whatever. Well, let's do the proper thing, which is to just stop counting at that point, right? It doesn't really make sense to keep counting after having reached attack. I'm rereading the code to see if I spot any obvious mistakes. So if we are not the maximum, start at 0. If we are the maximum, add 1, but cap it to this. We have an auxiliary function for this, don't we? Yeah, we do. But I will not use it now. So this form doesn't read as well, but whatever. Then I check if I am not the current camera and enough time has passed in terms of attack, and enough time has passed in terms of hold, then do the camera switch, which looks like this. Okay, I think that everything I see makes me happy. Let's do the whole setup. We have to turn on video, and this is going to be track 1, and here we will have track 2. And let's turn off hold for a moment. This slider doesn't really have the range to go down to 0, but it so happens that you can type any value and JSFX will just take it, and that helps us test stuff. Without any hold and without any attack, I expect the camera switch to be very fast. Oh, it's not going to be instantaneous as I was thinking because of RMS. Because we are smoothing this value to begin with. Let's see what this looks like. Yeah. And the weird thing is happening here where we are predicting the future. We don't have any look ahead. We don't have any... No look ahead, no latency, no samples of latency. And yet somehow we are able to predict the future. It's so odd to me that this happens. I have no idea why. And it is consistent too, see? Anyway, at least this transition is making sense. When there is this transition, it is immediately cutting to the other person. Now let's add a little bit of attack to see if we broke anything. With attack, what I expect is for the two transitions to occur a bit later. Exactly, like this. Perfect. Now, let's turn off attack and turn on hold. So what I expect to see now is for this camera switch to occur very fast, but then for this other one to take a long while to occur. Just like this, perfect. Yeah, I think that this is what we wanted. Except, of course, for the crystal ball feature, where it looks into the future somehow. Let's review the changes, and perhaps we will even get to this threshold that I was not expecting to have time to do today. Oh, boy, so much talking for this much change? Sometimes it's like that. Let's see what you have to say, and then I will try to tackle another feature I want for the Automixer for video. Isn't that just because the tracks aren't actually processing in real time? The track you are recording probably has higher priority or whatever? First of all, I am not too concerned about this in practice, because if a camera switch occurs, that split difference we saw there was about, I want to say, like 200 milliseconds, 100 milliseconds, perhaps even less than that. So I should actually measure this. But anyway, I think that if a camera switches 50 milliseconds off the mark, it's okay. No one is going to care. So I'm not worried about it. But what you're saying is that the processing is not happening in real time. If the track that I'm recording has higher priority, I guess you are right, because Reaper can look ahead. Oh yeah, that is something. Let me explain things. It's such an edge case, but it is a possibility. So Reaper has this feature, I forget its name, is like predictive processing, something. What it does is, when you have a track that is not recording, Reaper knows what is going to show up in the future because it can look ahead in the timeline. And the track is not recording, so it can look ahead in the timeline. And then it can process effects in samples that are to come, which is useful because it makes everything faster. When you get to that buffer, you have already processed the effects for that buffer. You are ready to put them out to the sound card. So there is a setting somewhere where you can turn this on and off, because there are plugins that don't like this. And I think that perhaps the Automixer is one of those. This predictive thing will process the audio from the future, but that will affect audio in the present, or at least it will affect camera switches in the present. And that is because we have a fancy way of plugging instances to communicate between one another. And that is an issue here on the scene transitions. It could also be an issue in the actual audio portion of things, because if the audio portion of things is out of sync with reality, we would be applying the gains to the different microphones according to data that is about to come, which is not exactly correct. Crap, this could invalidate the whole architecture we are going for here with the distributed architecture for auto mixing. Distributed programming is complicated. Okay, that's the name, anticipative processing. That's what Reaper is doing. Boy. we'll play around with actual recordings and see if that is a problem. But maybe I will have to turn this off. Oh, you can disable this per track? I didn't know that. I only knew the setting that was sort of global. Yeah, we'll have to see if this is actually something we can hear. Is the camera switching supposed to work completely separately within each group? Yes. I think that the point is you would have completely separated groups in terms of cameras, in terms of audio, in terms of everything. Because the way I think about this is really that 5 people in a room, 3 people in another room, Skype call, that sort of thing. So perhaps you would do an auto mixing of one room here, one auto mixing of another room there, and maybe you would have a split screen situation. Maybe you would want a third auto mixer instance just for video to auto mix between the two groups. So I don't know. But yeah, right now I think that the camera switching is supposed to work completely separately between groups. All right, so let's not worry too much about this weird situation and just move on to another setting that I think we should have, and that is, I guess I will let this be a test for hold. And that is when 2 people are talking at the same time, then the differences between the voices may be fluctuating between, like, we are talking about milliseconds here, but the gains will be fluctuating very fast, which again could lead to weird situations. It could lead to fast, I guess not fast camera switching because of attack and hold, but it could make it switch to someone who is just saying yeah in the middle of someone else's sentence. If they're saying yeah very slowly and goes beyond the attack. So what I'm going for here is I want not only for a microphone to be the loudest, I want it to be louder than the rest by a significant margin. And this is actually not the threshold that I had in mind. It is a minimum difference. So yeah, the point here is, right now we do this comparison to determine that we are the winner. I want this to be not only comparing to the maximum, I want it to be comparing to the maximum plus some minimum delta for it to be the winner. And then I suppose that this will help. Haven't really tested, haven't really heard of any user complaining about this, but it's something that was already in the Automixer for video in the original implementation. It is this notion of the minimum change. So if 2 people are speaking, then we may not switch to anyone's camera right away. Is that a good thing, actually? I don't know, I guess because we don't have enough time to think about this, let's do threshold, because that's easier. If everyone is quiet, it is a bit odd, but it could happen. Especially when you're using this live, and in a live stream, sometimes you are quiet and you're thinking about something. So let's not do any camera switches if we don't reach a certain threshold, because if you haven't reached that threshold, it means that everyone is quiet. And that's going to be another slider. So we have attack and hold. Let's have, oh, I guess I will put one of the separators here. think it makes sense for the threshold to be first, actually. Did I spell this right? Yes, I did. And let's say that this, to begin with, will be something like -30, or even less than that. When you think of this in terms of like gates or something, I think that a threshold of -40 may be a good value. And you may go from let's say 150 up to 6 if someone is clipping in steps of, let's say 5 dB, well, 1 dB. Yeah, good. That looks good to me. So now let's go to everywhere where we see this and apply that as well, because this is another one of the group parameters that need to be linked. Did I pick -40 or -50? -40. Then this is another field on the data structure. 0, 1, 2, 3, 4, 5, 6, 7, and 8. Naturally, we are not converting from milliseconds to samples, but we are converting from dB to linear, because we have a slider in dB, but we want this to be working in terms of linear. In fact, even in terms of 0 to 1, we'll think about that in a moment. I guess we will want to copy these lines. And then something like this. And then that. I think that does it. I think that now we have a slide that syncs. Let's try. It is good that it's not showing up right now, and then I turn video on, and then it shows up in both, and then I can play around with it, and it is in sync. Perfect. Let's review the changes real quick. Okay, everything looks good. Then all we have to do is change this condition. It's not only the case that the gain is above everyone else, but it's also the case that it is above the threshold. Just like that. I think that this is exactly what we need. Let's check this by duplicating this region. Nice. And we'll call this the threshold. And right now, if I just play through, it is going to switch scenes. Why would it be? Because maybe the threshold is already too high? Hang on, did you see the meter moving here? No, the meter moved there. Okay, so maybe this region is too small. Let's make it larger. And really, we don't need this. But I will need another copy. And can I extend this region? Yes. Okay. Let's try this again. It's not switching. Oh, I think I know why. I didn't set this track number. Okay, so as you can see, it is switching to different people correctly. But if I make this to very quiet, it should be below the threshold. So it should not be doing the scene transitions. It should switch to this person and then get stuck, even if there is signal here. And I will want to test this below and above the threshold. So I'll have one item here below the threshold and one item above the threshold. And the scene transition is only going to occur after we reach this part. It's not working. Why is it switching back? Did I remember to reload the plugin after having implemented threshold? I may have forgotten that. And threshold is -40. Still nothing. Did someone catch a mistake? You could probably also do gain is greater than the maximum between the others and threshold. Correct. Yes, you could collapse these two. It is a different way of writing it. I think that the way I wrote is a bit more intention revealing, but I do get that this is more elegant. Yeah, but I think that there is a problem already and it's probably not working because of this problem. And that has to do with the conversion between dB and linear and the values we get from that and this. So let's recap. What are the numbers we get in this dB to linear conversion? Because I don't remember. But I do have a test effect I can use. So I will import the library and let's compute dB to linear of something like -40. Also -150. Also 6. And let's give this names. So we are getting numbers between 0 and 1. Unless, of course, we are clipping. Well, that's a nonsensical value because we normalize our gains. So you're never supposed to get here. Let's make this slider a bit saner. And realistically, you shouldn't be going up to 0 because then effectively you're turning off, but whatever. I'll just let this be like that for now. And when we have 0, we have 1 come out, right? Yes, 1 comes out. So this is giving me numbers between 0 and 1 correctly. Okay, so what's up with that? Why are we never above the threshold and, or not that we are never above the threshold. Why are we above the threshold when we shouldn't be? That's the question. So this is definitely below the threshold. And yet it is triggering a scene switch. I guess I will want to see the value of this variable. It does not matter in which instance I see this. But I want to see it. It is 0.01. That makes sense. It's a value between 0 and 1. That makes a lot of sense, yes. And I guess now I would want to see the gain on this, on the offending track. I will want to see the gain on this track. And I want specifically to see that as I play through. Did you catch that? It seems like here, that's a large value. Oh, I see why. I'm normalizing the values. That's the problem. Gain is a normalized value. I shouldn't be comparing against gain. I should be comparing against the RMS, which is an absolute value. That's the problem. I'm comparing against the wrong thing. And because of that, this max approach will not really work. Let's revert to our previous approach. So with that, we have no changes to the file. Well, we do have the range that we changed. So we will not be looking at gain. No, sir. Gain is the wrong thing to look at. We will look at something else. What we will look at? I think it's called RMS or something. It's really stupid. Do we want to look at that with priority? I want to say yes. I want to say yes. Yeah. And I think I will want to look at the version of RMS because we do a lot of shenanigans with RMS, right? We add priority to it, or we multiply priority by it. We compute look ahead. So we do a lot of shenanigans. I think that the thing I want is to use the version we use to compute the gain. The gain will be RMS with priority with look ahead. I think that's the version I want to compare to. So if my RMS with priority with look ahead is greater than a threshold, then you are allowed to consider doing scene transitions. I think that does it. Yeah, whatever, I'm removing you. I'm also removing this. I was thrown off by the good old normalization problem. And that's what I'm talking about. I don't know why this scene transition was so fast. Well, the whole period was already over, but why didn't attack kick in? And why is this scene switch perfectly on time now? Is the predicative thing not working now? What the hell? What happens if I make the attack bigger? That works. That's perfect. Yeah. It is delaying the scene transition by the tiniest bit. That's perfect. That's exactly what I was looking for. Awesome. What do you have to say? Shouldn't it be the level the winning track is above all other tracks maximum rather than a set threshold? Shouldn't it be the level the winning track is above all other tracks maximum? Oh, I think I see what I mean. Yeah, so I have two different notions. I explained both and I implemented one so far. The notion I have implemented is the notion of threshold, which is just don't switch cameras when everyone is quiet. Because you are probably about to switch to someone who is like breathing louder because everyone is quiet. So the winner is just someone who is breathing louder. It's just noise. It's probably going to be a bit random anyway. Or someone who has a microphone gain set up a bit higher so it gets more of the room, whatever. So that's the threshold. It's just don't try to switch cameras when your overall level is below the threshold, because that's probably just someone breathing. Then there is the second notion, that is the maximum difference, which I also explained, but I didn't implement yet. And perhaps we'll do that on Thursday. But that is the notion that you are talking about and the notion I explained before. I don't want necessarily to just be above everyone else. I want to be above everyone else by a small margin. And that's significant when there are two people talking at the same time. So that's the minimum difference between microphones. When multiple people are talking at the same time. Yeah, all right. I think that's a wrap. Not much has changed, just one line, but that's a good sign. Okay. I'm glad that makes sense to you. So, with that, the schedule is that tomorrow we have Dale over to talk about clap. I'm really looking forward to that. Then on Thursday, we will get back to the Automixer, or maybe on Thursday we'll take the day off, because on Friday probably we will stream with Aria. We'll see. Anyway, For now, thank you Mage and Tail and Bo for and Seawits for joining me on the chat. Thank you to everyone else who is watching this, supporting me on Patreon, and giving me feedback about all the work. Yeah. Oh, I'm glad you liked the code session. I liked it too. We were able to do even more than we expected. Yeah, all right. See you tomorrow. Have a good one. Bye. Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.